Okay, it looks like we're live. So welcome back. Today I'm going to be continuing to work on this Turing machine, like an emulator basically of a Turing machine. I'm writing in C. So here's what we got so far. So it's not very much. It's 100, little over 100 lines of code. Let's see. This is what the program, right? Let's see. This is the instructions, right? So there's basically a series of states, and then based on the current element that you're looking at, it'll do different things. And you can write programs that sort of consecutively execute things to achieve things. So this is basically a binary incrementer, so it'll go up by one each time. And it reads where the left is the least significant and right is most significant bit. So it's sort of like flipped of what you would be used to usually. Yeah, so if I run it, and you can actually pass as a command line argument the binary. So if you, let's say we have that, it will increment it by one. So yeah, as I said, this is the least significant. So that'd be that would be, how does it work? One, yeah, so that'd be 4, and then it becomes 5. Pretty simple, right? Yeah, and that one actually just goes to 0 when it can't go any farther. But yeah, you can also make it larger than that, and it will just increment it by 1, basically. That is how it works. And yeah, so today I'd like to make it basically infinitely expandable. So as it keeps going, it will it'll basically expand as much as it needs to. Because that's how it's supposed to work. It's supposed to be what is essentially just an infinite tape, at least off to the right. It could be off to the left as well, but for mine it's just going to be cut off at the left, so it will only expand infinitely to the right. And then also I want to make it so we have more options than just binary, right? So we can have different characters on the tape as well. So yeah, basically what I'll do is I'll replace this data with a tape, right? So tape, and that'll be basically just a what's called a dynamic array. So we'll have the data, which is still going to be a Boolean for now, and then we'll have the count and capacity, right? And I just will replace these with tape, right? So I'm going to have to change some of the code, but that's okay. Go up here and maybe do I'll do tape randomize, and we'll take one of those right there. Right, I'm just changing it so it's more general for the future, right? For something I'm going to work on very soon. Take count actually now. We're going to go to the capacity, like the whole capacity, but then the count will just sort of what we've used so far. Okay, data, we still have data. Yeah, so that should work now. And we have to update this where we randomize it. So where do we call, we call that actually anywhere? Yeah, right here. Okay, so this will be tape. There we go. And, right. Hey, how you doing? What is up? Right, so then we'll allocate that, and we'll set, this sets it to whatever we have here. Alright, so that should work. And then, when we're putting it out, we need to do tape data. Right, so this is going to make it so we'll be able to, if we go too far to the right, then we'll just basically extend it by however much we need to. Probably just double it each time and just fill it with zeros. I think that makes sense to do. Should I use the count? Turing machine like the guy that cracked Nazis' Enigma machine. Yeah, yeah. It is Alan Turing, yeah. Yes, indeed. Let's see. Alan Turing, right here. Yes, that is the guy who designed it, basically. And it's named after him, of course. Yeah, you can read about it here if you're interested. Yes. So I think I want to use the count here. Let me think. Because we don't want to print out necessarily the whole thing, just the count of what we used so far. Do we even need the count, actually, really? Not sure. I just usually do that for the macro, but I'm not sure I'm going to use the macro. I'll just sort of write it out. We'll see. Okay. Tape data. So this needs to be updated as well. This needs to be capacity. And so this is going to this is where we're gonna reallocate it, right? So let me actually make a block here, and then I'll put a to do here. So reallocate. A few years ago, you were into cryptography and even figured out how Enigma machine worked. Really, it was simple to build, but it's difficult to decrypt because you need too much info about the current state of the machine. Right, yeah. I should look into that. That could be fun to make. I don't know too much about it. Like, obviously, I know of it, but not really how it works. Right. Yes. Let's go to the. It's not there. Okay. So they don't have that there. That's a cool thing about like cryptography, though. That like it can be pretty simple, but almost impossible to crack, right? To decrypt. Very cool. Send you a video if you're interested. 30 minutes long. Yeah, I would be interested in that for sure. I am familiar. I am no stranger to watching long videos. Let's see. So yeah, we need to. I think that's pretty much all of this. Now we can just look at what it says here. Yeah. So that is in here. All right, we need to update this. I think I do that actually. Set it equal. Yeah. So we do that. Okay. Data. Right. Only 20 minutes. All right, I will actually save that to the watch later, and I will watch it. How did the Enigma machine work? Yes. Very cool. I appreciate the suggestion. Yes, thank you. Love videos like that. Capacity, right? You want to allocate based on the capacity. Not just the size. So this needs to be capacity. Yeah, here as well. Capacity. There we go. Whoops, I pressed the G key. Alright. Where else? Oh shoot, I need to move this. Alright, no memory name capacity, let's go. Whoops, I forgot the dot tape. There we go. That one is right, so what's the other one? Nothing named size, right here. Yeah, so this is actually going to be the capacity as well because we're setting. Alright. Yeah, and it doesn't work now. I wonder why. Anytime you wanted to explore Golang, alright. Planning to build a TUI Git client, nice. Don't know if you've ever seen a Zozin's Emacs Git client, but you want to build something similar. Yeah. For sure. Yeah, I know what you're talking about. That could be cool. And Go is pretty good for that, like TUIs. I haven't written too much in it, but I've seen, like, it seems pretty good from what I have seen. So, what I've heard. Yeah, we don't iterate the count, so that's where the issue comes in, I think. Let's just go to the whole capacity. Alright, there we go. So now we can do that, and it does not work, actually. It doesn't set it properly. Because we do this here. Oh, yeah, because we want to iterate over based on capacity. Because we're setting. Being used a lot on the web and TUI. Yeah. Yay is built in Go. Yeah, for sure. Love Gay. Love a good TUI. Go is good for them. Roll your own library to write TUIs in C++. Nice. Is it a public library, like on GitHub? Right now it should work. Yeah, there we go. Okay, so now it all works. Works in this way. So now we need to reallocate as we get to the right. So let's see. Yeah, so basically we don't really use the count, so I'm not sure necessarily. Right, so this is if it's to the left, so we won't worry about that. Yeah, public. Could I see it? Okay. Yeah, so right here we need to just reallocate basically. So if well, actually we should iterate the count as we append to it. I guess we don't really append to it, do we? But if the head is there, then we can just yeah. Oh, you're fetching the all right. Very nice. Raw term. Yeah, I'll look at that in a second because that sounds pretty cool. I'm not very familiar with C++ though, but I've used it before. But Zig as the build system as well, very cool. As a build system at least. I've not used Zig for that. Okay, if well, we only have the machine head, so we just need to set machine take.data equals so we do need to set it all with zeros. So maybe we should allocate a new one. Right, we should allocate a new 0 and then set tape equals. I'll just allocate, right? And then I'll just copy everything over based on the previous capacity, and then yeah. Let's see, I think it goes this way. Size of. Can I do that actually? Don't know if that would work. So let's not do that. Okay. Not one, but rather the new capacity. So machine tape dot well tape dot capacity. So what's that? Tape dot capacity. Okay, I'll do that. Yeah, do that, and then don't know if you can use Go in anything different from the web and TUI. Would like to try it anytime soon. Just in a language that has some high-level features, but it must be compiled and strongly typed. Right. It's Python to build things fast and C for everything else. It's in a language in between, which I believe Go can be. Yeah. I think Go, yeah, it's pretty good for that. Odin as well. I think Odin's pretty good, and it's a bit lower level, so it's a little faster than C because it doesn't have the garbage collector and stuff. But yeah, I think Go is a good choice for that. And, Go's obviously more mature than Odin. Yeah. No, I need to copy it over first. So we will, go for his 10W. Very true. Times machine paper capacity. Yeah, is that right? Go lives directly between C and Python. Want to like Go, but found something's buggy too much. That's fair. Link pretty much any C library to Go. Yes, very true. There are packages that already did it for you. Due to K bindings, there is one called Whales, which is similar to Electron, but lighter. Oh, I've not heard of that one. Whales. Yeah, most languages allow you to do that for sure. Whales IO, is that it? Oh, here we go. Beautiful applications using Go. Hang on, I gotta see that. I haven't heard of this, but it's pretty big. Pretty big. So it's like you use JavaScript for it. Okay. I see. That makes sense. Similar to Electron. Right. Yeah, I haven't heard of that one. That's pretty cool. Right. So it did double the capacity, but it still set everything at 0. So that's not exactly ideal. Maybe you don't want to return that there. There we go. Okay, yeah, so then that does work actually. Because that would be iterating by 1, so. Okay, that's pretty cool. Yeah, so now it'll expand. It doesn't expand by 1, but that'd be kind of inefficient. But this is where the count would be useful. With the client you're going to start building, be uploaded in the AUR. Alright, believe it can be something that people may actually use. 80% of your projects are just cool projects to learn, but not to use. That's fair. Relatable. Allocating booleans with calyx. Yes. It's going to not be a boolean soon, so I don't really care. Yeah, I'm going to use a character probably. Can write rather than x86-64, but you don't think there are a lot of. That's fair. That's fair. Brain freak. Right. Yeah, it'll be a character. And then you'll have more options, but it's just easier to leave it as a boolean for now. Right. Yeah. So I want to keep track of the capacity or the count. So if we iterate the head, so you have generics. Cause there's not really generics now. No, there is not. And I think there's like certain macros that you can use that are kind of like that, but it's not the same thing. So no. Tries to circumvent generics, reverse implementations, macros, and codegen helps. Right. Yeah, I don't care about that, so. Generics are too high level. Very true. Let's keep track of it properly. I do need to check to make sure it's not 0 though. Oops. Kernel data structures linked list. Let's see. Just head in it. Right. Felt like you need generics in C when you started writing it, coming from Java and Python. Right. I'm using, yes. That makes sense. Yeah, it gets kind of complicated. Okay. Type up. C++ or glib. He wants to use C++. Nasty. I definitely do not need that. C++ brings more issues. So true. I need to set this in here as well. Okay. Yeah, so it doesn't bring out necessarily if it's interesting that would not set it. Any of those I can set here. It'll always be at least that. Use C++ a lot. It's fine. It takes more time. I don't know. I never really liked it. I guess I haven't used it too much for like anything big, but I've used it some. Now it does grow. Okay, that's good. Actually, if it equals 0, then we won't get it here, so we don't really need to check that. So that's fine. You need to finish all the stuff you're currently running and planning to write in C++. Never can finish everything. 3 types of C++ step. Those who write it like Java, obsessive OOP, right? Those who write it like C, and those who are in between, which you are part of. Alright, so you use it like how it's more intended, right? As far as I know, that's sort of the intended purpose, right? Very nice. Okay. Didn't say C++ in your last message. What? Did I say C++? Did I say that? This could be different. These are the same. We need to allocate it. Okay. Hidden behavior is 3. Learning isn't meant for virtual function bindings and private multi-layer inheritance. Just write your code in plain and simple way. Right. Makes sense because it would unify some of functionality that has sense or is relative to a unique object. Right, that makes sense. Makes sense. Okay, yeah. So, basically, so now I'd like the tape to be able to be, have more characters. So, to do that, it's going to be interesting. Basically, just the alphabet and the numbers. So, like, yeah. Well, yeah, probably just the whole thing. I'll just use characters for it, I think. So let's try that. I did change this now, but that's fine. Like, I don't know if that works. Since it's not, like, I don't know if I can get the first element. I think that would break it. This would be like that thing. Besides what OOP offers, it's just a matter of syntax. Right, yes. Yes, indeed. Okay. So nothing's really going to work now. It's going to be kind of broken. I guess you guys still work using characters. I guess that makes sense, but... So basically, let me think. C likes many features, and C++ has too many features that you can't even count. Wish there was a sane in between. C+, yes. How about C3? C3, Mr. Zilzen's been using it. I don't really know too much besides what I saw there. Where is it? Wait, was it C3C? Oh, it is this one. Okay. Yeah, C3C. Have you looked at that at all? Yes, indeed. Yes, indeed, he did. W string. No perfect language. Yeah, absolutely true. Perfection is impossible. Yeah, I don't know if this is actually very good or not. I haven't used it myself. Watch some of his videos. It looks fine, but needs more tooling for recognition. Yeah. Well, that makes sense. Okay. Yeah, so now, this needs to be character as well. So we need to change that. Its biggest competitor is Zig, you think, whose biggest fault is its instability between versions. Alright, that's fair. Eventually it'll become stable though, right? Even C can't link C headers. Relatable. May not use all those features. Some developer guides and companies like Google recommend not using certain features that C++ has. Yeah. Right, writing C like a C or a Google developer. Only when Zig does a 1.0. Yeah, which who knows how long that'll be. Yeah, so now that just use that. So that's not right. So this program is supposed to work with binary though, so it's not going to exactly work. Also this. Also that. Where is the randomize? Is that not right? Oh right, I need to do unsigned character. Yeah, that's important to do. Same size, but I'll do it anyway. So I don't want it to be negative. Okay. Right, block the message. I'll allow that. The guidelines, however, you still need to know most features unless you're going to work in the same company. Right, that's fair. Hey Stam, how you doing? Like OOP because it will eventually become a mess. Interesting message. Right, so it just devolves back into binary, but that's because of the instruction. But it does work with that. So the issue is we don't have the option for that. We have yes and no, so it needs to be instead an array to state sort of the value, right? Value. It's going to be an array, and we'll do 2 for now. It's still going to be binary, right? It'll be limited to that. Controversial in DM with Cactus. How controversial? Saying you like JavaScript, is that what it is? So that everything's going to break, right? But then we can have each one, a different one for each value that we want. Don't ask, okay. Let's see, really this is going to be like that then. So I'm going to put that back so I can get call. This needs to actually change to that. Oh, no, it doesn't, because it's the same. Alright. Rid of this as well. More controversial than Cobb, bro. C++ has the diamond problem, which results in a messy inheritance between multiple classes. Java has the same problem, but for interfaces, since you can't extend multiple classes in Java. So you don't stick to OOP that much. Rarely use inheritance, but a class is not that different from a struct with fancy functions. Yeah. Golang is like that, indeed. Classes are bloat. Very true. Structs are kind of bloat too, you know? Just use to structure yourself. Whoops. Just don't even structure your program. Let me think. Is that right? I don't think I need this here, though. Do I need that? Actually, I might need that. Oh, let me think. Well, yeah, because we have that. That's this. So expected should be part of that, then. Yeah, part of this. That makes sense. Yeah, so then this is what we expect. And then, I don't need this. So then if it's 0, then we do these things. And if it's 1, we do these things. And then that could be expanded, right? Include more. It doesn't like that. So like that. So really now it's just an array of these. When you compile a class, it becomes a struct with 4 additional functions. Bruh. No, please, no. Or push-ups. Okay. So right, so we have, this is the array. And then these are the structs within the array. So I think that works. Okay, and then we need to check here. So instead of just this, we'll have a for loop, right? We can loop over this. So I'll actually define here. So this will be, no mistakes, right? Rust structs best. Very true. Rust is actually just the best language. Impl for anything. Very true. So we loop over that. Now let's check. So if it is equal to, we take that beta is equal to inst instruction value I. And we want to do these things. Right? Oh, we need the value I, yes. Index it. Because it's an array. Drawing syntax. I hate typing additional words for no reason other than pleasing LOVM. Love LOVM, it's the best. I like your types on the left side based. Always wondering what how languages allow changing a collection while iterating over it. Bruh. No while loop in Go was a fun thing to explore. We basically just use the for loop for that, right? While loops are kind of bloat anyway. Right, that gets rid of all of these pretty much, because it's just the same thing. And don't forget here, we'll, I don't know, maybe we'll just assert false, because I'm not sure if we should ever get to this thing. We'll see it. Now, we need assert. Yeah. Let's see, there's something else I need to do here. It doesn't look like it. Okay. This needs to be actually defined. Missing bridges around. Yeah, so it doesn't like this. I'm not used to using this. I usually use allocated structs. Writing meaningless code to explore the language took you 5 minutes to understand why wall wasn't a valid keyword. Bruh. Go performs worse than Java in any benchmark as a compiled language. Yeah, well, you know, it'll get better, right? Yeah, it doesn't like that thing. This is an array of instructions that are an array, or contain an array, right? So is that not good then? I'll need to write this. You write this comment as well. Java is also a lot older, to be fair. So like, as time goes on, Go might catch up. Also, they're doing some stuff with alternate allocators, so that might improve the speed as well. Like if you don't have to use the garbage collector. Perhaps. Because I have, well, because it's an array. This is the element. So we need like that. I know, so let's see to keep track of. That did. Okay, so we did get the assertion here. Execution time in Java is consumed by the time it takes you to write the code. Very true. So it's similar to Go performance. Very true. Facts. Absolute facts. So this failed, but also I need to constrain this. So I'll use the states. That basically corresponds directly to it. Do anything larger, then it will fail. Yeah. Because it does not match it. But otherwise it'll work. So then if we increase it, yes, this goes here if it's out of bounds. So maybe I'll just value is not in expected range. Oh no, it doesn't do that. What? Oh, because it doesn't get to there, that's why. Yeah, I need the new line as well. Sometimes Go is faster, sometimes Java is faster. That is flashbang. Let's see. Go. Number 3. 8 seconds. Right. Okay. What's the number 3? Macho 9 followed. Thank you. Appreciate it. What does that mean? Oh, so it's just a differently written program. Okay. How is it so much better? Let's see. So let's look at what's at the top. It's like we'll assume best case scenario. Also uses a lot less memory. Like in every instance. So, I mean, that makes sense, but Java is faster in those tests where the JIT compiler can optimize everything, right? Used to watch it months ago, seems like you improved a lot. Yes, definitely have. Yes, when I first started I was kinda crappy, not gonna lie. And I didn't know C at all, so I'm much better now. Yeah, Go seems to be like, okay, here it's not. Pi digits, okay. Yes, that's like a JIT thing. Push through, yes. Just do that and, you know, study a lot. Okay, I'm getting distracted now. Yeah, that makes sense. The JIT here. That's interesting though. Yeah, it does seem pretty comparable though. This one Java. Binary trees. Yeah, Java kinda mogged Go here. Yeah. So like about half. Okay, so that works. It will print it out the first time, but if we do that, then yeah, so you have to expand it, right? Expand the instructions. So I need a better way to write this, but these Go isn't necessary. OOP, very true. There's not really OOP in Go, right? Except there's like methods or whatever. See, we can expand this. So it's not going to work probably, but we can make it 2, right? 0, 1. So if the value is 2, and get to 1. And yeah, just repeat that. We can change this to all the functions at the top. We can 0 to C. We got 3 values. Yeah. Still reverts back to binary, but interfaces and methods, yeah. Yeah. But it's not really, like, it's not really OOP enough to be, whoops. No, I messed it up. Stop caring about languages a long time ago. Very true. We're watching the VM videos by Azozin. His machine looks like your machine. Well, I sort of started based on that, but it's actually deviated a lot. Don't know why it's a conversation. Very true, Stamp. Just use Rust. I think that's the message. Right, so this could be expanded now at this point. So I will commit that. Expand more values. Okay. Use Java at work and it makes you money. You give the same amount of money to write Go, you'll use that. Right, that's fair. The only thing I wouldn't write is JavaScript. Except I probably would write it, but you know. Okay, let's see. Examples. Let's see, it's gonna be hard to write this. So what's the best way to perhaps do that? Right, because we have the structure and then the array within the structure is what this is about. This is the array within it. Yeah. True, very true. JavaScript. JavaScript is the best. So yeah, then we could have more instructions. We just basically need to copy this. Inst gen. Well, see, but that's not quite what I would want. I'm gonna pass the array in there. I'm trying to think how the macro should look. I'm making it. Right, and then yeah, you just do the next one. But it would need to be wrapped in parentheses as well, so then it's not really much different. Finally finished the evolution project overview. Let's go. When are you gonna release that? 34x timelapse, bro. I want to write any weakly typed language. Even writing Python is kind of difficult. Use MyPy to check for obvious errors, but one thing you don't like in Python is you can't annotate the type of a variable, but it doesn't mean that necessarily will match the exact value. Right. That's fair, yes. Yeah, in Python, you know, it's Python, so I don't want to do that. C doesn't have strong type checking either. Very true. So what if I do it like that? I don't know. Maybe that's not the way to go back. I maybe should make user input. You know, you can create it. The user can create it. What? What? Yeah, so we ask the user to create the instructions. How would that look? So you need one for each instruction. So instruction, basically the instruction just contains all of these. And then you could do next instruction. I don't know. Let's create more like this. Change it back to binary. Right, and then these are basically the different states that are possible. Let's see. So what is a... I don't understand exactly. Convert any type to any. Manipulate any function pointer to any other. Trick to jump an instruction on another function. Enums are just integers. Pointers are a size type. Yes. Pass any numeric type to any numeric receiving function unless a GCC flag is enabled. Very true. Can you have an arbitrary type in a hash map implementation in C? Void? Void pointer, right? Do I have it in mind? This is mine. Yeah, void pointer value. And then you just have to allocate it, I guess, and then just give a pointer to it. There's also some other ways. Just requires a bit more work. Well, you know. Right. Yeah. I don't remember exactly how I implemented that. But yeah, it would have to be allocated then. Because if you're pointing to a stack element and then it goes out of scope, you have some problems. Can use char star, assuming any data is byte. Yes, you can use that as well. There's a few different options. Why was it not an inspected range? See, that doesn't make sense. So why did it get there? What? What? Oh, shoot. Wait. What did I mess up? It did not match with any of them? What? Oh, because I had this extra one here, that's why. It's a problems. There we go. Okay. Yeah, so I'm trying to find a different program. I should have looked at this before the stream. The union way. Well, that's a bit of a problem. Take up the size of the largest element, which is not ideal for this case. Yes. Very true. Maybe. Yes. Not maybe. They do. Let's see, like a program. Turing machine example. Onions, as you would say. Yes, very true. Love onions. French, you say, how are your onions? Or how are things going? What? What does this mean? How are your onions means how are things going? I'm a little confused. So is this... Try that. This would be A, and this would be B, and this would be C. Right, so instead it's just 0, 1, 2. So make the 1. This one moves to C. Italian, you say, how do you stay on your legs? To mean the same thing. What? I don't understand. I don't understand. Take to the left. Right, so that might cause some problems. Print symbol 1. Okay, that works. And then here, 0, 1, 1. This one goes to the left. A lot of noise, sorry. Let's go back to this. Stupid Euro peons. Very true. You can also say it's not someone's business. Ce ne sont pas tes ongnos. Oh no, I can't do that. Not your onions. So this is now C. Yes, we want to C. 0, then change it to 1. And go back to 1. Okay. So how do you halt? I don't think it'll halt. Okay. I think it does. I don't think it works. About a kilogram of olives. Bruh. It's a jar full of olives. Like green olives? Olives so ew. Yeah, I'm not a big fan. Not a big fan. Yeah, but how's the halt? Where's the halt? The head does not seem to move, and it just kind of ends. Two. Is this wrong now? Is the indexing wrong? Hang on. Well, it shouldn't be. Green, yeah. Purple, yeah. Also like the dark ones. Black olives, yeah. Like the food that tastes good. Relatable. Watermelon's good. Fish is alright. Not a big fan. Current. I just returns that, and then instead, output the current is current is 0. Yeah, when is it doesn't change. I've never tried fish. Oh, the eyes of cows. Wait, what the heck? I've never had that. Building our own kernel when? You gotta ask Noah on that. Noah is the senior kernel developer. Cooked head of a cow with the brains, and that's interesting. Very interesting. 1 goes here, but then it doesn't go to 1. Because it should go, well, hang on, let me look at it. It starts on 0, which is negative. Wait, I don't really want to print that out. Okay, let's look at how it works. So it starts on 0, so it goes to the right. Then it goes to the next instruction. So it's on the next 0. And then if it's 0, it goes to the left. It sets... Oh, and then it goes back to this one. But it sets it to 1. So now it becomes 1. And then it goes back here. And then it's 1. Oh, shoot. Okay, so we need another... See, I'm not sure if this is an actual 1. I'm not sure where it comes from exactly. Also, I don't know what it's supposed to do. I should have read that, actually. 3 state, 2 symbol, Turing machine. Present state table, which defines the machine's behavior for each possible event. So this is the state table. That's what we're writing here. Eyes kind of explode too. That sounds interesting. Very interesting. Machine example demonstrates the machine's ability. Okay. Yeah, where does the example come from? From here. Flashbang. Let's see. So, how's it supposed to work? So it goes to the left here. It goes back to 0, and then we're on 1. Oh, so then it tries to go to the left. So then it halts, right? When it tries to go to the left again. Oh, do I not check that anymore, actually? What does that do? So we do that. Oh, then we just return this and we exit. So let's actually let's print an error in this case. Right, so that's what it is. So it prints an error, and then we don't use that. Wait, what? Oh yeah, I see. Yeah, so it goes out of bounds. So that's what the problem is. I don't get exactly what we're supposed to do though. Let's see if there's another example. Let's see, is this gonna be? Yeah, let me turn on the dark reader. Dark reader. There we go. And it's gone. Okay. I want to see the table. Okay, let's look at the state. Let's see. Let's have a good one. Flashbang. Just chat in French and Italian. Bro. That is very, very much a light page website. No, it is not. Genius. State is 1. Input is 0. Then right is 0. Transition to state 1 and move right. In state 1. Right. So this is basically the state name. So B is N. So this is basically 3 things. Wait. B is the end. So like, okay, the end of the tape. It's not exactly the same though. American brain can't understand the European pressure. Very true. So what is the end? Let's see. Infinite storage tape partitioned into cells, an alphabet of symbols, a read-write head, the machine state, that. Okay. So machine to that state, right. So B is blank symbol. So I don't really have a blank symbol. Do we need that? This one only has 2 states, really. So the input is what you read. How did B end? B is blank. Yes, you have 0, 1, and blank. Sun mentioned in the chat. Big if true. That'd be 3 states. We say, and we can just we'll use 0 as the blank. Can we do that? Or should we use 2 as the blank? Yeah, let's do that. Okay, let me try it. There's 3 for each one, and there's 2 settings. Let's do this one. So 0, 1, and then 2 is the blank, right? So we'll imagine that. And then set it to right is 0. Okay, 0, right is 1, and right is 0. Move to the right. Each one of them moves to the right. Oh, all of them do, okay. Transition to state 2, 1, and 3. 2, 1, and 3. So 2. So 3 is the end. So really it's going to be 2. So it's going to be 1 less than 20 because we start at 0. So they're all right. I know that. And then if the input is 0, 1, and then 2, oops, 2, right is 0, right a 1, and right a 1. Transition to state 1, 2, 0, 1, and 2. Okay, so 2 would be hold, right? I'll probably be able to get rid of that. Next goes forever. Very nice. Maybe that's not the end of it. Does it never transition to that one? Do not write 2s. Hang on, let me write a 2. It still does. Okay, 2 is out of the way, so why is that? How does it not match any of the characters? Because it should be... it should match them. One, two, three. So when it gets to the 2, it says... why does it say that? Because we match it in all 3. Has machine exploded? Very true. Need a new one. Yes. Ain't even reading. Well, I can't read that. Yeah, I only speak Americanese. 0, 1, and 2. That's what we have. Why does it say like? So that means it doesn't match any when we print that out. Unless I'm stupid. Yeah, no, it just means it doesn't match any. But it should. So why does the 2 not match? We have the correct number of states. Thought you knew Italian and French. No, I don't. I'm an American, so. The King of Europe? You are the King of Europe? 0, 2, 0, 1, 2, 0, 1, 0. You never write 2. If we do anything less than that, then it just goes forever. If we don't have any zeros. Oops. So worse on the first one, but the second one is not. Next one. Let's look at what that would look like. So 2, so we're on 2. Yeah, and then we finish go to the hold stage, which it does not. Because now the instant figure. Right, because well, it's 3, so that's still right. You're the president of the USA, very true. American patriot, very true. So 1, 2, 3. So we have 3 elements. Let's print out the current again. Current becomes 2. Oh, value is not in expected. Yeah, it goes here. Doesn't equal any of them. Why does it not? You know what the value is. Well, yeah, we'll print it out. We'll print it out as an integer. Data machine 10. 2. Right. Why? Comes closest relative, not American born. I have no idea. Probably the yeah, I don't know. I was gonna try to make a joke, but I could not think of anything funny. Why is 2 not in the? I don't get that. I don't get why. So we iterate over this. Print the expected. It's value I expected. Oh, you know what? Because it's all 0. Okay. So we need to break sooner. Hang on. Let's just let's see. Cobb is the real American, born in democracy land before dirty Europeans came here. Very true. That's kind of, wouldn't say that. Would not say that exactly. 69 AD. That was a while ago. I remember it well, though. I remember it very well. Let's just return into that. Right. Let's get rid of the extra things that we're printing. Yeah, so that goes forever. So that is a problem because, well, why does it? Yeah, it has to be 2 to get there, and none of these set it to 2. Can I do that right? Yeah, none of them do. So this one, yeah, 2 is 1. BC, BC, because it's before Christ. So it's AD and BC. How does this work? You're right. 69 is a meme for the association. Ah, yeah, you could say that. Yes. That is correct. Also, yeah, I think most Western countries do, right? Hmm. One 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 two 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 three 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 four four four. Right. So what does this do? But it's 0 and 1 plus B for blank. Right. Tape input is sequence of 0 and 1s. Right. And what is the input here? So it never writes 2 though. So how do you? It never writes blank. Yeah, but what's the input meant to? Input meant to be? Sequence of 1s. Yeah, but then it goes forever. So, alright, let's try this one. But is 0, 1 plus B for blank? Tape input is sequence of 0s and 1s. Okay. Number of 0s and even number of 1s. I'm GUI is sometimes so annoying. Working with it right now. I've not used that before. I'm GUI. I've heard of it. Looked free. Oh yeah, for C++. Yes, indeed. Why is it annoying? Bruh. Bruh. It's written like C. Right. You can read the code. Yeah, I probably can. GUI. Let me see. Let's look at an example, perhaps. Examples. There might be an example in the readme, but I don't care. Vulkan. I probably can't read that. Yeah, okay, let's find the let's just go to the let's go back here. I changed my mind. Immediate mode. Hello world. That then do that. Okay. Input text string. What does that mean? Oh, okay, that's the label. I see. Okay, yeah, pretty simple. Well, that looks pretty cool. Okay, yeah, it's pretty simple. The immediate mode things. Yeah, I don't do a lot with GUI, so I don't know very much about it. Very cool though. Okay, let's try to find some more examples. Let's see, does this have the table? Okay, yeah, so this is one. So what does this do? What does it do? Here's one. What's it meant to do though? So if it's 0, go to the first one, set it to 1 and move to the right. If it's 1, go to Q1, set it to 1 and move to the right. So that's the same thing. And then if it's B, then halt. Okay. Wait. No. Oh yeah, if the value, okay. Right. I could try that, but what's it supposed to do? Two states. Type alphabet is, yeah, 0, 1, B. So we'll just use 0, 1, 2 for that. And its input alphabet is 0, 1. Probably go sleep. Need to sleep well, because tomorrow you continue packing for moving yourself to a new flat. Alright, have a good one. Have a good one. And good luck. Good luck with that. Good night. Blank symbol. Right. But what does this do? Ciao. Yes. Ciao indeed. What's the purpose? Let me try it. So 0, so that's this one. If it's 0, 1, or 2, so that's what we have here. If it is 0, then write 1, move to the right, and go to the second one. If it is this one, do basically the same thing, yes. And if it is this one, then halt. So that is just moving to 3, so that's, we don't have to worry about anything else there. For this one, if it's 0, write 1, move to the right, and yeah, go back to this one. If it is this one, go to Q0, so that'd be this one, move to the right, and, or move to the left, rather. What is the L here? Right L, but you cannot. How does that work? Does it mean move to B? I'm a little confused. I might be wrong. Au revoir, real. And this one goes to 0. B, so it's writing B, right? Right to move to the left. That might not be right. So when it reaches a 2, it'll halt. The second 2 as well. What instance does it set it to 2? Not in here. But if we do, if we encounter 1, we move to the right. And then if it's another 1, set it to that. That one gets stuck. Interesting. Yeah, 2. Yes, that does not happen. Okay, so it will halt. Relay chair. Relay chair. Alright, let's see. It's another example. I don't really get that one. For addition, let's see. Does this have... Yeah, it has that, though. How does that work? It's a lot of stuff. Ayo? Sus? Sus among us? Let's see. I want a simple one. I also need a tape. Okay, here's something. 0, 1, X, Y, B. So we can use anything for that. So B is blank. Q0, that's the initial state. Alright, it always is going to be. What is question mark? Alright, let me try that. So there's 4 things here. I don't know. 3 and 4. But yeah, 0, 1, 2, 3, 4. Yeah. So then this one always goes to halt. Or it just doesn't do anything. I'm a little confused actually. It doesn't have all the states. So we don't have every possible thing here. Yeah, maybe, whoops. Maybe I'll try, what the heck? I'll try a different one. This is the one we just looked at. Yeah. Where's just, alright, here's this. Right. Let's get rid of this. As long as you have two 2's next to each other, it will eventually stop. Okay. Yeah, I have to go pretty soon. Let me try to find, I want to find a good example though. I will do another stream on this. Especially if I don't find an example. I also don't quite get what it all means. A lot of stuff. Busy Beaver, okay. So ABC is actually 1, 0, 1, 2, right? So if it's 0, write 1, move to the right, and change to state B. Yeah, so I implemented this, but how does it work? How does this work? Right, I can do that, but let's see. So 0. So yeah, we need 3 different states. Oops. This last one. Halt. Halt is 3. Merce. I can't pronounce that. Pour the stream. Okay. Gotta translate the thing. I know a few words, but you know. Thank you very much for the stream. Yes, of course, of course. Let's see. Move tape. Stay. Right. So we want to stay. So ending stay. I think. And something is broken, and I cannot use it. What? What? I don't know what happened. It wouldn't let me move. What? Cobb speaks French. Big news. Very true. Very true. I'm actually fluent in French. Rate simple. If it's 1. Alright. So yeah, there's only 2 here. If it's 0, then write 1 to the left. And then go to B. And I need another one. What happened? Okay. Yeah, so this is B. And this one actually needed halt, so that's going to be 3. So B is 1. Yeah, Okay, perfect. Here, again, if it's 1, then write 1, move to the right, and go to B, which is this one. Okay, goes to A, move to the left, and write 1. Okay, here, last one, 1, so I'll write 1. That's interesting. Move to the right, this one moves to the left, this one goes to C, and this one goes to B. That's wrong footing. Okay. Out of bounds, dang, because we don't support 2 in it. Oh no, it went to the left, that's the problem. Yeah, because it doesn't expand to the left. French is greater than JavaScript. Very true, very true. Okay, if we start with a 0, then it's fine. What does it do? State drawing of that. The internal sequences of inch required. Start on. Okay, wait. Let's look at that. So start on 1, 2, 3, 4, 5, 6 zeros, and out of bounds because it went too far to the left. And also didn't work. Wait, it did this. No, it didn't do that. So what if instead of exiting, we just set it? Just, don't change it. That would. What the heck? We've already solved with the Turing machine. How do you mean? I haven't solved anything. I made a binary incrementer, and that is pretty much it. I gotta spell return. That's not right. Yes, that's not how it's supposed to look. Well, here... Oh, it halts, though. It almost worked, but then it just stopped working. No, right? For real. Very true. Let's see. So is there a better thing, perhaps? Turning a program of given size that produces the most output possible. So it's supposed to run for a long time. I see. Is this gonna be flashbang? Yes. Let's see, what is here? Any ones possible before halting. It only prints out 2 though. So then it goes back to 0 and eventually it halts. That's not good. So what if we start in the middle? Will it work? Try that. So get rid of, where is it? Get rid of this. And we'll set the head equal to just middle. Capacity divided by 2. That's turning into a lot of 1s. Is that how it's supposed to look? Right here. This is the middle, right? Make it short. Hmm. Not sure. Yeah, it just goes between 0 and 1, though. It does fill it with a lot of 1s, though. Okay. Alright, yeah, I have to about go. So I will put some more research on, for the next stream, on different programs, and I'll try to implement some of them. Salut. Yes, indeed. Okay, let me see. Make sure that worked. Perfect. Alright, yeah. So thank you guys for watching, and I'll see you next time. Goodbye.